questions? One. Two.
So I had one.
So with it, is there like a stream? Is there where automatic in the background where you feed all the data feed, or autonomous data feed that behind the scenes streams all the data, collects back to you so you can refine the data?
Yeah, so obviously we have some sort of a data stream from the users to our sort of data center in order for us to understand that. Somehow, we're still very, 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 very cautious about privacy issues. Okay, so we're working gently in this space.
Wow.
Yeah.
Where do you find that you're more far from the dream? Like where is it most lacking, this feeling?
So I would say that it's still unknown, okay? And the reason for that is because the field is very, very young, and there are not a lot of companies that work in this field. And this is what guides us, for instance, to be very careful in our strategy in approaching the customers, and we're currently engaging in beta experiments because of these things. But I think it's a combination of how to make mistakes gracefully. Okay, this is one very important thing, and the other one would be what is really the most important thing? Is it function or is it interaction? Okay, and it's a hard balance between
as you said before, lowering expectations.
Yeah, perfect. Okay, last one or? Okay, you can just talk to me later. Okay,
Exactly.
I'm here.
Thank you very much. Very good. I guess catch him afterwards, since we have to move on to the next lecture. All right, so our next lecture is Zhay ZWEIG.
Yes.
Head of AI at Intuition Robotics. Zhay and his team combines the research and reduction to practice practicing of state-of-the-art algorithm decision-making, robotics, vision, dialogue management, and more. Zhay has a PhD in neuroscience from the Parallel University, and his unique research combines studying of visual system in the brain with investigating deep learning for computer vision. And Zhay will share some of his work and his team in adjusting the robot's personality to the user using online learning, and how active learning helps to get to know the user better. And I'll let you continue.
So I can try without it. Let's see how it goes. So hi everybody. So thanks for the introduction. I'm heading the AI efforts in Intuition Robotics, and I'm going to tell you a few words about who we are and what we're doing, and then give you like a brief overview of stuff that we're dealing with and interesting challenges from developing what we develop, which is basically social entities or social robots. So what we do in the company, or as a tagline, is that we're developing intuitive and delightful proactive AI agents and reshaping the way that humans and machine interact. And we're focusing our efforts in two main fronts. The first one is building the cognitive AI engine, which is basically a decision-making engine based on algorithms from different fields, from computer vision to NLP and to classic cognitive computing. And basically this drives decision to create some sort of interaction which is tailor-made to the users, and it's a multimodal interaction. Okay, so we're creating some sort of using different modalities to create the best interaction possible, and we have experts in our team in the fields of human-robotic interactions, which is a very interesting field. on its own, and they are creating, using design tools and other tools, the best experience possible for the users. And what I'm going to share with you today is a little bit of the experience that we gathered from creating our first product, which is LEQ, this cute little robot, which is a social robot for the elderly population, which is its main goal is helping with the loneliness problem, which a lot of the elderly individuals suffer from. And I'm going to tell you a little bit about that, and we're going to meet LEQ a little bit further ahead in the presentation. But before I go into the details, I want to talk about, in general, about what is the social entity, what is the social entity's world, or the artificial social entity's world. And I mean, we all get this notion of how AI would take control of the world in the future from the film industry. But I guess we're slowly and methodically starting to create a lot of processes autonomous, right? There's a lot of autonomous technology being built right now in many very, very great companies. And I think that looking forward, we'll see a world in which a lot of things are being done autonomously. So from the cars to the delivery guy, or to maybe a grocery salesperson. Each of them can be automated in some way. And when we think of such a world, we need to have some sort of a way to communicate with those machines in a pleasant way. And we want to be able to live in this world and like this world that we are creating. So there is a need for some sort of a communication layer on top of these autonomous systems in order for us to communicate better with these machines. But the thing is that communicating with the machine, or making machines communicate with people, is quite hard. We are not very patient to our AI friends, and we all got, like in our community, we got a very big reminder of that lately when the Gebo launched. I don't know how many of you know Gebo, but Gebo is maybe the first social robot. Okay, so it's a company that went out from MIT Media Lab, which is one of the world leaders in human robotic interaction, and they wanted to create this really, really cute social robot with a general purpose. So it's supposed to be somewhat of a family member, and they kind of launched late last year. And I want to read a review that the Wall Street journalist wrote about them. Okay, so just to show you what I'm talking about. So this is what she wrote. I get out of the shower, grab a towel, and walk into the kitchen. As I fill up a glass of water, a cute little robot, half Wall-E character, half Clorox bottle, rotates his body in my direction and says, Gebo, oh hey Joanna, welcome to my field of vision. And me saying, Gebo, please don't look at me right. Okay, so kind of awkward. And we all can think about this situation, right? So in terms of algorithms, it's like a very minor error, right? Like this one rule that somebody maybe forgot to enter into the system, or maybe the lack of ability to recognize this complex situation, right? But this ended up as the title of the review. Okay, this cute little robot made my family mad. Gebo offers it links to the future of home robots. Should it be in your home? Absolutely not. Okay. And this review and others kind of killed the product eventually, which means that there is a very, very high cost of failure in this area, and anybody who wants to even try to compete in this world has to take this into consideration and think about how to gain the user's trust. Okay, and there's a lot of tools from UX areas and from the product perspective. To solve this problem, I want to talk a little bit about the algorithmic side of this. So stuff we're doing around AI and algorithms to help us get a better experience from our social companion, okay? And the first thing I want to talk about is proactivity. So we all, when we imagine a companion, a friend, we want him to engage in the interaction also, right? We want him to initiate some of the interactions and not be the only one to initiate interactions. And most of the social, of the personal assistant that we know today are reactive in their nature, right? We have to tell them what to do. Alexa, play music, Siri, what time is it, and so on and so forth. And we believe, and we know this from research as well, that in order to create a real connection between the human and the machine, we need to be able to initiate interaction from the machine side as well. And in order to do it, there needs to be some sort of internal motivation for the entity to act, okay, and to make decision on the fly. And we call this, and we're not the only one, we call them the goals of the agent. So let's speak about multiple goals and how we live in a multiple goals world. And I'm going to use an example of a hotel receptionist, an AI hotel receptionist. And for those of you who've seen Altered Carbon, I hope he's less violent than this one. Anyway, when we're thinking about a hotel receptionist, so he has multiple goals, okay? And we can divide the goals of this receptionist to categories. So there are goals defined by the user, okay? So in our case, the user is the tourist. And the tourist might want to get the best service. He doesn't want to feel lost in this place that he's visiting. He wants to find a good restaurant and maybe know about some events that are going on in the city while he's there. But there are also other types of goals. We have goals that are driven by the agent itself. So for instance, the agents want to get to know the user, okay? And he wants the user to like him, okay? This is something that is preferable for the agent. But there are also goals that are driven by the business that stands behind the agent. Okay, so in this case, it's the hotel, and the hotel might want to drive people to use the hotel bar, okay, because it wants to get as much money as possible. And it can also want to recommend his partners in the city and so on. Okay, now we can think of these goals as buckets that we have to fill up, and eventually we want to strive to have most of the goals filled up most of the time. And now, how do we assess the state of these buckets? We can do some sort of passive analysis of the state. Okay, so for instance, using computer vision, we can sense that the tourist is currently looking at the list of events in the city. Okay, and then we can determine that we can fill the bucket or find out about city events, for instance, because we saw the user looking. And on the other hand, we can also sense that somehow that the user is looking around in the lobby, and then maybe say that we want to, we feel like the not feeling lost bucket, it needs to be empty, okay, because the user is feeling somewhat lost, okay, and so on. And then we want to try and change this, okay? And how do we do that? So as a social entity, we have a bunch of interactions that we can engage in, and we basically correlate those interactions with the goals. Okay, so how do we do that? That's a very, very good question. So this can be a combination of using expert opinion, which we are using, and also learning. So this is one place when we're using learning as part of the system. We can learn how to connect each interaction with different kind of goals, and we can also use some sort of contribution score. So, for instance, we can look at offering a complimentary drink at the bar. So offering a complimentary drink at the bar can contribute to the goal of using the hotel bar, and it can contribute to the goal of getting best service and also getting to know the user to like me, maybe. But it can also increase the level of the not bothering the user, okay? Which is a very important goal. If you think about it, a very social agent, you don't want to bother your user. This is one thing that we're really emphasizing, the balance between being too aggressive in proactiveness and still engaging in proactive interaction, okay? So we can think about this different kind of interaction, and then we can calculate this contribution score, and basically what we want to do is get a weighted, the best weighted sum of this contribution, okay, for the goals. And another thing that we can add to it is some sort of a priority score, which is also learned between the different goals. So each agent can have some sort of different priorities in terms of the goals that it wants to fulfill. And also this is something that can change given the state or given the business. So for instance, we can have some sort of, I don't know, an offering, a limited time offering where we want our user to use Uber because we have this promotion going on with them, and we can then push the goal of using partners over other goals. Okay, so this is an interesting dynamic framework that allows us to promote proactive interactions. Okay, now the challenges here are obviously how to define these priority scores and how to define the contribution scores, and this is where we're putting a lot of our efforts. And as I said, one of the tools that we are using in order to do that is learning. And in order to learn, we need data. And this is one other challenge that we are suffering from deeply, which is how do we get data in this world, right? So labeled data, yeah, of course. Yeah, of course, correct. And here we need to be very creative because collecting data in this world is somewhat challenging, given the fact that there's not a lot of people living in this world. Okay, not a lot of companies or academia people doing work around this. There are, but it's not as common as, for instance, computer vision for autonomous vehicles, where you can get a lot of data. And this forces us to be a little bit creative about how to collect the data. And this is what I'm going to talk about next, is how we're using active learning in order to gain this data. And when I'm saying active learning, I'm talking about a specific kind of active learning. So we have this challenge of getting data about our users, and specifically we want to know as much as possible about our users, right? So you can think about it, there are multiple items of information that we want to find out about our users, like their preferences, their hobbies, their personal history. So for instance, since we're approaching the elderly population, I would like to know something which is kind of esoteric, but the population that you're approaching are the guys, especially in the States, the guys that might have participated in the Vietnam War, for instance, okay? So this might be interesting for me as a social entity. Why? Because I can maybe create interactions that are related in some way to this, okay? And it will create the connection between us much stronger because I know him a little bit better, right? But how would I get data about this kind of things? I mean, think of the model of trying to assess if somebody participated in the Vietnam War, collecting data in 2018. Probably possible, but kind of hard. So what we're doing, and also we have a very limited sources of information. So we can use questionnaires, we can use some sort of population-based recommendation system maybe, or something like that. And we can also passively collect some data. But our advantage over passive platform is that we can actually ask questions, right? So that's nice, okay? So think about it, instead of trying to invest hours on hours of creating a model of assessing from computer vision if the person participated in the Vietnam War, I can just ask him, right? Did you participate in the Vietnam War? Now, probably not this way, okay? I wouldn't do it this straightforward, and it probably wouldn't be the first thing I ask also. It's like, hey, I'm LEQ, did you participate in the Vietnam War? Not the best way to go. And so we need to try and understand how we can collect this data, okay? How we can use this active approach in order to collect data about our user in the best way. And this is kind of, when we frame it, it's kind of a simple problem, but it can gain a lot of information relatively easy. So this is how we frame it. We think about it as, we define a lot of information bits that we want to gather about our users, and this information pieces are defined by the product team, okay? So we can have multiple information bits, and there's also, we're starting to think about work of how to automate actually the information that we want to gather, but let's say that somebody defined it for us, okay? And then again, it's usually the product team, we think about many questions and how they that can help us gain this information. Now, it doesn't have to be straightforward, okay? We can think about multiple models in order to get some sort of a hierarchy of questions, for instance, which can contribute to some information more than others. So for instance, if I want to know if our user loves dogs, I can ask him a general question about did he ever have a pet? Okay, now it doesn't have to be a dog, but if he had a pet, it's more likely, okay, that he likes pets, and it's somewhat likely that he likes dogs. Now, it doesn't have to be that way, right? But we can actually calculate how much each question contributes to each information by, and we basically want to calculate the information gain. Okay, using information theory, we can somehow quantify the information gain that we will get from each question to each of the information items that we want to get in terms of probability or confidence in the information item. And eventually we want to try and, we want to try and prioritize them and maybe attach a score to each of the information, but this is the V here, okay? So there's a different value to each of the information pieces. And we might want to quantify them together and figure out some kind of a score, okay? Weighted score of the information gain that we can get from each question, and then periodically we can sample from this and decide what questions we want to ask. Of course, we need to remember that the no question is probably the most important part here. So usually we don't want to ask any question. This also needs to be calculated into the model. Yeah.
How about inconsistencies? Like, especially elderly people, their memory is not that good, and any person has stories and they revise them as they go. So this is a nice model if you consider that the answer you get is truthful and correct.
Yeah, so I don't think I care if it's truth or not, because I want to be his friend.
No, but
And if he told me that he was in the Vietnam War, then I believe him.
and
Okay.
it tells you that he was somewhere else at the same time.
Yeah, I'm okay with it. Okay, so of course it can pose some sort of a challenge, especially in this population. But I guess this is in the edges, right? Usually you don't get this. Okay. Yeah.
Do you have an algorithm for devising just keep them talking type question?
Yeah. So yes, it doesn't fall into the pure algorithm area because it's UX, right? You want to try. One of our goals, and it relates to the earlier item, is to engage. Okay, and sometimes we just want to talk.
What's that?
And so, what? Sorry, what's that like? Yeah, so we're thinking about ways to engage interaction with the user. So we have this like interesting facts. Okay, did you know that blah 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 blah? And then if the user responds in some way, we follow up with another. Oh, so do you like this and that, and so on and so forth, and we try to engage in some sort of interaction. We're thinking about how to deal with long stories, because especially the type of population that we're dealing with, they love to talk. And we're thinking about how to deal with it, because clearly we can deal with it, and we don't want to give the illusion that we can, because we don't want to pretend that we're more than we are. And this actually helps us with this. So two other advantages for this framework is, first of all, that we are limiting the expectation. Okay, we're saying we don't know, we ask questions. Okay, and the second thing about this is that it strengthens the connection between the user and the platform, okay, and the agent, because basically, I mean, you want your friends to ask you question, personal question. Okay, so just by trying to gain information, we also increase the goal of just getting a strong bind. Okay. So I really have like short amount of time, so I want to move forward a little bit. And
Let's do questions at the end.
okay, so and there's like the most interesting part I think comes after this. So this entire thing is really, really nice, but we think that this would be very lacking if we didn't have the last layer, which is what we call the personality of the robot. So you all know that, okay? That if you engage in interaction, even with a social entity which is artificial, you still get the gist of the personality. And I guess you all talk to Siri, or some of you may talk to Siri and talk to Alexa, and I guess you all think that they have different personality. Okay, Alexa is a little bit more, a little bit nicer than Siri. Siri is very polite and very politically correct. At least this is the way I perceive that. And we think that the personality has a very important part in the engagement, and therefore we want to try and personalize the personality. Okay, make the robot personality as the most fitting to the person that it's supposed to engage with. And I want to show you a small example. So this is LQ, by the way, and I'm sorry about that. I realized this morning this presentation obviously was made for a different conference, and then I recorded it with the name of the conference that I visited in. So the name that he's going to say is not our meetup name, but you will forgive me, I'm sure. And I don't have actually sound here, do I?
You can connect. How do It should be.
It should be? Okay, let's try. Okay, so this is one LEQ. Okay. Oh, no. Wait a second.
Just turn the sound on after
Yeah.
it says the name of the conference.
Can you hear that?
Yeah.
Okay, so let's try this again.
Good morning, fellow robot lovers. Thank you so much for having me here today.
Okay, so this is one LEQ. That's a different one. I'm doing kind of the same thing. You don't hear.
Wow, that's a mouthful. You figure with all the brains behind this event, that is 466 million.
Okay, so for those of you who didn't hear, she was a little bit more cheeky here, okay? So I call them the cheesy LEQ and the cheeky LEQ, okay? So this one is very nice and polite, and she's saying, hello, thank you for inviting me, blah, blah, blah. And the second one is kind of sophisticated. She tries to tell you something like, why did you pick such a long name for this conference? Never mind. But the idea is that you can get a very different experience in terms of personality, even if the function is similar, okay? And we want to try and personalize this. And to do that, we need to define personality, which is, I think, the most challenging part here. And the way that we define the personality is we think about it as a personality space, which is spanned by axes that are the personality traits. So for instance, we can think about humor and endearment as kind of traits that you can have some sort of a different level of humor, a different level of endearment. You can think of other traits as well. And this is like, for instance, you can think about persons that relate to these places in this space. So for instance, I don't know, Mel Brooks is very funny but not very endearing. Oprah is maybe very endearing and not very funny. And then you get Ellen, which is maybe both. I don't know. I didn't put it there. But this is a marketing slide. But this kind of shows us what we mean, right? There is some sort of a way to define personality in a space. But even if you think about it, we are complex people or complex entities, and therefore when you think of a personality, it's more likely that you think of a distribution, right? You're not always funny, and you're not always very lovable, okay? And it depends on a lot of things, and even if you don't consider moods, which I will consider in a minute, there is some sort of a distribution which you live in. We still might be more tilted to one way or another, but it's still a distribution, okay? So we think about the personality distribution, and then again, we also have this level of the mood, which is a state-dependent thing, right? So for instance, I might be a very funny person, but when I'm in, I don't know, a board meeting, I might try and relax a little bit. And on the other hand, when I'm with my friends and I had a few drinks, maybe I'll be a little bit more, I don't know, funny, but maybe funny to myself. So we think about this filter, which we call the mood filter, which is a filter that is applied on top of the personality distribution, and basically the end distribution that we sample from is some sort of composition between these two distributions, okay? And then the challenge is assessing the distribution. And we can think of many algorithms to try and assess it. I guess most of you can think about it, but a very simple algorithm can be something like defining an initial personality distribution, then sampling, and then let's put the mood aside, but we need to also assess the mood, and then sampling from this distribution, the momentary personality, okay, which defines how to interact in this specific interaction, then we can measure some sort of feedback and refining the distribution based on this feedback, okay? Now there are, again, don't have time to get into the details here, but there's a lot of very interesting questions here about how we define this feedback, this reward function. How do we measure if we succeeded in our interaction and if it was due to the personality, okay? Because there is a lot of other noise in the background here. We want to keep the variance kind of high because we don't want to collapse to a specific point and be always very, very funny, for instance. We know this doesn't work very well. And we need to try and learn and think about how to learn the mood and also deal with high dimensionality if we want to move in a space where we don't have only two traits. But all in all, this gives us a very, very nice framework which actually works today of adjusting the personality to the people that we are engaging with. That's it. Now, I just want to say a few words to summarize this, that I think I personally, and it's not because I'm doing it, It's because I personally find this field is a very, very interesting field for us, the learning people, the AI people. And the reason is because I think it's kind of a convergence of a lot of different fields into one very interesting place. And I find it very, very interesting. I think that you will find it very interesting, and we're looking for people. So please talk to me if you're looking for something interesting. Thanks.